Glad to have Mr. Shane Roche from Steelhead Company. So he got his bachelor in physics from George Washington University and focusing on nuclear physics. Then he served as, for 5 years, he served as in the Navy and was stationed in Bremerton, Washington on USS Connecticut, a nuclear-powered submarine. After that, he joined Vestas in 2020 and spent 2 years over there. And in 2022, he joined the Steelhead Vestas North American Development Arm. He has experience on working on projects in MISO and WEC. And right now he has been working on Whitman County on Harvest Hills wind from the very beginning of the project. So we are glad to have him. So he will give us a very interesting topic and discussion on this topic.
Yeah, I appreciate the opportunity to be here. Took my intro, but we'll skip through that slide. But kind of just to let you know what I'm going to talk about today is just kind of our overall development process. Normally, who Vestas Steelhead is, kind of touch specifically on the Harvest Hills Wind project that I'm developing. But feel free to ask questions at any time. Hopefully, this can be as the most informative and useful that it can be for you guys. And can everyone virtually hear me pretty well?
Yeah, I think so. You are in
Yes.
Awesome. Also joining, we've got Adam Solomon, who's on our team's transmission, or my team's transmission team, and kind of focusing on supporting in our interconnection efforts. And then Eric Slusher is on our public engagement team. So you did a great job introducing me. Grew up in Boston, now live in Portland, Oregon. Circuitous route to get me to where I am today. Vestas, we're the world's largest wind turbine manufacturer. In the United States alone, we've got over 24,000 turbines installed, hundreds of sites, and we're the best wind turbine company, unbiased opinion, in the world. So if you ever on a project recommending a turbine, recommend the Vestas turbines. Vestas is part of the life cycle of a project from every stage. So my team, we're the Steelhead development team. So we're the North American development arm of Vestas. We have a focus across the entire United States, theoretically Mexico and Canada, but we really only develop projects in the US. But then Vestas, we develop projects globally, but our biggest business unit is manufacturing, where we manufacture the turbines. We support in the construction and commissioning of the turbines and bringing them online. And then the operations and maintenance through the lifetime of the project. And then decommissioning, and we'll help reset build components at the end. But what I do and what I focus on is the development period. So everything that happens prior to construction, and what this entails is land acquisition. We have to do lots of studies to make sure to bring our project online, from measuring the wind to environmental studies. I think what you guys are most familiar with is our grid interconnection process, for us to be able to bring our generator online, and then permitting and design. And I'll dive deeper in these, but kind of that's the overall big picture of developing the project. And land is, I think what we see as the most important and hardest thing to do. So when we pick a project, our team, will do a lot of desktop studies and figure out, say, okay, from a desktop review, the wind resource here is good. We'll look at distance to transmission lines, because the further away from a transmission line, the more expensive it will be to connect to it, but also harder because of the land rights we have to acquire. And then any known environmental risks, maybe permitting risks, and kind of figure out before we even go into an area that it's de-risked as much as it can be. And then it kind of gets handed to me, and I'll run the overall process of getting it from nothing to ready for construction. And the first step is land. Without land, we can't do anything. And the way we operate is entering into lease agreements. So, we work with farmers, normally because we're in agricultural land, and entering, about a 50-year lease term to host wind turbines. we believe we're, not believe, like we know we're a compatible land use to farmers, and that on average, a turbine will impact about 1 acre of land, and that's including the roads and collection lines and infrastructure of the project. And meanwhile, the rest of the land is still able to be used for the farming operations. And then just because of like siting and having to separate our turbines, I'd say we could probably need about 200 to 300 acres per turbine. So that's for every turbine, 299 acres that is still being able to use for the farmer. But on top of, land, just being able to have it for because we need to be able to site it, we need to have access to do all our studies. And then I think the biggest thing that, until I started working in development and understanding is setbacks. And so, if I lease 10,000 acres, that doesn't mean that I have 10,000 acres of land that I could site a turbine anywhere. So the first thing that we'll look at is, setbacks from, either like state regulations, or in most cases, it's the county regulations. And here in Whitman County, we have to set back 4 times the tip height from residences, and then mostly 1.1 tip height from other structures. And that's, a combination of, protection, worst case scenario, in the rare event a turbine were to fall over, things are protected. And then the residences have a further one for annoyance of just looking at it, shadows and things like that. But, without land, we don't have a project. And land, these are all voluntary lease agreements. So that's just what we spend. I've been working on this project for 3 years, and we're just coming to the end of our land campaign of being able to have the land rights to potentially build our project. Yeah. So then, the other, this is the picture of the existing Palouse project, by the way. Other parts that we do in our process, we have to have at least 2 years of wind data validating that the wind speed, we can see with satellite data, like what we expect the wind speed to be, but we need on-site measurements just to validate it, but also to help figure out site specific, like, okay, this area is actually windier and we'd rather, have a higher producing turbine here than that. Environmental studies, every region's different, and Washington has some very stringent environmental regulations that we have to meet. So, we've done multiple years of avian studies to measure bird populations, to making sure that we minimize and mitigate any impact we have to birds. We've done some critical habitat studies and making sure that we don't impact any critical habitats. Going to the spring, we have to do some detailed wetland studies as well as cultural. Washington is very, takes the tribal relationships and cultural history very seriously. And so now that I have an initial design, we're going to have to essentially walk every square inch that will potentially impact to make sure and mitigate any risk that could make sure we don't impact anything that has cultural significance. I think what you guys, I've kind of looked through some of your guys' seminars, have a good understanding of transmission queues, how a utility studies it. Avista, who we're connecting with, is actually relatively quick. Going through MISO, we've got projects sitting there that are just been delayed for like 5 years. PEGM's pretty bad. But so we expect a long time for the queues. One thing, again, with the interconnection queue, you have to have, before you can even apply, you have to have land. Different utilities, different transmission operators have a lot of minimum land requirements to, make sure that your project is real prior to even entering the queue. And as you go through, there's probably higher land requirements to validate that, the project's actually there and it's not a false, just like a dummy project to get market intel on kind of where network upgrades would be and things like that. And a big thing with like the interconnection queue too is that's one of our largest costs on our project is, when they tell us what our network upgrades would be, that's kind of, probably the single biggest cost is us paying the utilities and fronting the cost to be able to upgrade to bring our projects online. So here we've actually had a pretty relatively low network upgrades, but we've seen projects die, when they have like $50, $100 million in network upgrades that the project can't handle. And then permitting is a huge part of our process. So, once, we're kind of have our land, done studies, we have some initial design, getting the permits, that is a Depends on where you are. It is can be a long process, sometimes pretty discretionary process. So like in Iowa, we, where I've got a lot of experience in Iowa, the counties are run by the board of supervisors, and there'll be like 3 to 5 members. And those guys, it really can be, they could just approve or deny your permit depending on how much they like you. So you could spend all these years of work and millions of dollars going through the queue, doing these studies, acquiring your lands, and then you kind of create a project, apply for a permit with a certain criteria. But at the end of the day, a lot of it is making sure that the decision makers are, supportive. And at the same time, there's a lot of public opposition at the local, state, and federal level to wind. And, all of our projects right now are creating, there's an opposition group for every project that we have. And it's in the permitting process that they have the greatest effect. And that's where we see, it's more of like a public information space of whose messages can get out, who can influence the key stakeholders to make those decisions that are beneficial for the community, and not, letting the opposition kind of get a seat at the table for that. So yeah, that's kind of our overall development process. Once we've permitted and we have, I don't think I've designed in here, but, we have to design the project, figuring out where the turbines are going to go, where all our roads, collection link lines, take into account our setbacks, making sure we don't have an impact environmentally. And it's permitted. We kind of package those projects up and get it to the point that it's ready to be constructed. We'll be bringing on a BOP contractor, someone who that cost will be like $100 to $150 million just to construct a project like this. And, they'll build it, and then, the owners will, operate it through the lifetime. For us at Steelhead, our business model is to get it to that point. We don't own it. We're kind of like a Ford dealership. Ford makes trucks and sells it. We manufacture turbines, and we get projects ready to be built, but someone else will own it. But then our technicians will service the turbines.
For that transmission study, interconnection study, if the upgrade is needed, you guys should pay for that, or who is paying?
Yeah. So it depends where. So like project I have in Iowa, the utility is upfront paying for the upgrades, but then we're reimbursing them for the lifetime of the project. Actually, Avista is kind of the opposite. We're fronting the costs of the upgrades, and then the project will get reimbursed through the lifetime of the project. Adam, is there anything else you'd want to add on to that?
No, you nailed it.
Yeah.
So the upgrades are adding a substation or like having new conductors?
Could be all of it. So for my project, Harvest Hills, the majority of the cost is that we have to build a new switchyard. But a lot of it is reconductoring. And Adam, kind of what would you say are big examples you see most often for upgrades?
Yeah, I think most projects have between like $10 and $20 million for their POI, for their point of interconnection, for a new switchyard or for a new bay in an existing substation. If there are additional upgrades, typically it's reconductoring the lines that are nearby or outlets for the project. And so as those costs go up outside of the interconnection point of interconnection, you can see that it becomes less and less feasible for a project the more other network upgrades that they incur.
Oh, okay. So if it goes to transmission planning, those kind of things, then you don't get the project. Yeah. So if need requires somehow.
It's really, we just need to look at what we expect to the biggest cost for a wind project is just the upfront costs.
Right.
The turbines themselves are going to be over $1 million a megawatt. The cost to construct it is probably, $500K plus per turbine. It's like, depends on where you are, but it's like incredibly expensive. All right, that was too high. Maybe like $300K a turbine. Depends on where you are, but like very, very expensive upfront costs. And then it's just a very low operating cost throughout the lifetime. because you essentially just have a big turbine up there that's capturing the wind when it blows. You don't have to pay for fuel. The operating costs are negligible. So that the network upgrades after the turbines and the construction is the biggest cost up front. And so it's really just like, does it pencil? Does it make sense? Do we think we could get a return on the investment or not? And so that's kind of where, if it's like, yeah, the $20 million range, depends on the site, but like for a 200 megawatt project is probably pretty common and usually can fit. And then if you start having higher network upgrades, it becomes like, is it worthwhile or not?
You also install micro wind turbines that are smaller in size and range.
No, honestly, we only do the large industrial scale wind turbines. So our most popular model right now, and the one that we'd probably be planning to put here in the Palouse, is the V163 4.5 megawatt. And I think, yeah, none of our turbines that we're selling right now, well, we're still manufacturing 2 megawatt turbines, but those are mostly for like repowers and like repowering old sites. I think all new sites right now we're looking at over 4 megawatt machines.
So we were thinking of establishing some microgrid within the campus, installing several micro wind turbines throughout the campus. So it probably requires less of these permits.
Yeah.
Because the size is smaller and you don't need to have large blades.
Yeah.
Just wanted to know if you also manufacture smaller ones or.
No, we only do big ones for large onshore.
What about for the installation only? If we procure micro wind turbines, can you help with the installation part or?
Probably not. Our teams actually, we normally even contract out the actual installation to large, constructors with like the crane operations massive. So that's contracted out. Our technicians will support with kind of validating that I think essentially everything's put together correctly. And then our technicians will commission it, essentially getting it, making sure I test all the components, both physically and electrically, and get the turbine to start producing energy on the grid.
Quick question on that spec. What do you mean by megawatts per hour?
That's a really dumb, I stole this slide from someone, but
Okay.
I should take ownership, and you're right, that is
Okay.
yeah. Well, I guess, yeah, that just doesn't make sense.
Okay.
Any questions? I guess, process, I guess our turbine model, I was gonna go kind of more into what I've done or we've done for Harvest Hills so far.
One thing I heard that for inventory of the equipment, other day somebody told me even right now there is so much backlog for transformer. Said that
Yes.
it takes 4 years for them to get.
Yeah, we're ordering transformers and breakers years in advance, for projects that even if we don't think like, earlier stage projects where we normally wouldn't want to have a high upfront cost, before it's been fully de-risked, we're ordering them with the assumption that we could transfer to another project if the project fails. But we are for this project, the earliest that our project is going to come online, Harvest Hills, is going to be 2027, honestly, probably 2028. We ordered our breakers and transformers either beginning of 24 or early 23, because we're seeing like a, 3+ year lead time for those components.
But you have a luxury of, because you have so many projects, even if you don't win this one.
Yeah. That's kind of the goal. It's like, because otherwise it would be, that would be our critical path item and delaying when we could bring a project online.
I have one question, like what's the mechanism for deciding the sites for these turbines? Like where to place them?
Yes, that question one more time.
Yeah, like what is the mechanism for like locating, like where should we place these turbines?
Well, first it's going and figuring out, okay, we take all the land that we have signed.
Right.
We figure out here's all the places we can't put it, and we kind of create a buildable area map. And then we'll give it to our wind and site team. We're like, okay, here's, they're going to look at the wind speed data we've collected on site to figure out, where the best places to put them are. But then, we normally set back, or the turbines have to be separated by about 8 rotor diameters in like the direction of the wind, and like 2 to 3 in the non-prevailing direction, just to minimize the waking effects. And then it's really just an optimization problem of like, what's the most amount of turbines that we could put on this land that creates, and so the value that we look at to figure out how efficient our project is, our net capacity factor. And, that's just taking into account all the different losses and figuring out, okay, like, do we want a higher megawatt project, but maybe a lower NCF, or like, really, we would just want the highest NCF. That's the one that pencils the most, and everyone's always looking for the most efficient project for the site, the land that we have.
But also distance to the transmission lines, right?
Well, yeah, so that goes back originally before we even start developing the project. Because once I start signing land and I have, a project area pretty fixed on like where it is, and even that, where our final project boundary will end up, will shift throughout the development period, because maybe these landowners over here don't want to sign up, but we have a lot of support. So it's pretty binary. If we don't have land, we don't have a project. So we'll go sign land over here and then figure out our way to like get over the transmission line.
You also mentioned that you need 2 years of wind speed data. Who collects those data? Do you do that, or?
Yeah, we do that. So, for example, on our Harvest Hills Wind project, we've got 3 meteorological towers that have been out there for over 2 years, just collecting wind data.
How about system study? Does it consider, because in the papers we have so many people say that, okay, if you have a power grid, where to connect this kind of power plants. So basically it goes all in the electrical network studies. Do you do that one actually or not? You just look at where the land is available and how the wind blows?
That actually is part of it. So Adam's team will go, like, we will look in an area that we think has capacity. We'll do kind of some of our own analysis, and that will feed into where we will even start. But then once we're there, we're kind of like fixed. But Adam, kind of what's the work that you guys do for analyzing like capacity on the lines before, when we're still in the desktop phase?
Yeah, we try to mimic what the transmission provider does in their own studies. We have PSSE and Terra in-house, and we use those tools to run power flow analyses and try to figure out how much injection we can get at different points of interconnection.
Okay, so then that's kind of okay. So, but yeah, okay. So then you have a power grid and you do the study, see that where you can inject the most, and then after that go after where you can buy land at that area. That's how it works.
So what's the order? Do you first find the land where the wind speed is usually available, or do you first see in what part of the power system it makes sense to have those injections? So which comes first?
So I think the initial power flow studies are kind of part of that initial desktop phase, because we don't want to, if we think that we're going to have to incur like $200 million in network upgrades, we don't want to start going there. So I'd say, yeah, that's part of the initial phase before we go out, and then we'll start trying to lease land. Yeah, but then we don't actually get the real feedback. Like, we'll do our analysis, and like Adam will do the analysis of, okay, we think this capacity is here, and here's maybe a rough estimate of what we think the network upgrades will be. But it's not until like the transmission operators actually study our project through the queue process that we get the real feedback of what we think the upgrades will be. Yeah, anything else?
The process can vary. There are multiple ways we can get to kind of that final answer. So maybe Shane knows a landowner who's selling a huge parcel that would be sufficient to start a project or start looking around there. And he'll ask me, how much capacity could we get in the grid in this area? Sometimes we're greenfielding, so trying to come up with new projects that don't have any development around them. So we can use our power flow models to figure out where there is capacity on the system, and then we can pass that to the developers so that they can put some other filters on it to see where potential projects could pop up.
Nice. Yeah, thank you.
Cool. Yeah. Construction period, we expect to last about a year. huge job creator. That's kind of the biggest plus for, just one of the many benefits and how our projects benefit everyone in the community. So we're expecting hundreds of jobs throughout the construction period because it is such a large project. And then over the lifetime of the project, multiple permanent jobs to maintain it through until its end of life. And then, the Harvest Hills Wind project is the one that I'm developing here just outside of Pullman. We're planning on having 45 turbines. And, as I said, each turbine is going to have less than, about 15,000 acres leased. But of that, 45 turbines, total impact is probably only going to be close to like 45 acres. And so that still leaves, 14,955 acres to farm, and our farmers can still, minimizes the impact to their operations. But we still, the farmers benefit because we're giving them revenue for the turbines and infrastructure we set on their land. Especially you look now, like crop prices are low, fertilizer prices are high. It's rough being a farmer, and this helps provide some steady sort of revenue for them through to help their operations. And we create the jobs through the construction and operations period of the project, and we generate tens of millions of dollars of tax revenue that kind of go into the community for roads, infrastructure, schools, emergency services. I think it's not everyone would agree, but I'm confident that everyone in our community benefits for these projects coming in. We're planning on connecting to the 230 kV line that runs kind of north-south from here to Colfax. Where we are in the project is, almost done with my land, going to have about 15,000 acres of land lease. We've been measuring the wind since 2022. We've been doing environmental studies since 2022. We're about to finish those up this year. I just got our initial design in a couple of weeks ago, and we're kind of in the process, ready to submit a permit. Now, we had been planning of submitting the permit through the county, but in January, the county put a surprise moratorium up, so essentially prevents prevents us from submitting an application while they're revising the ordinance. And that's kind of why we're here this week. Tonight's actually a planning commission meeting where the planning commission will be talking about revising the ordinance, and our job's going to be going out there and making sure that any revisions they make don't prevent our project from coming on. What's lucky for Washington is that there is a state process called ESIC, the Energy Facility Siting Environment. What does it stand for? It's a statewide siting group that was created in the 70s, more for nuclear, but in the last 25 years has been been used for renewables. And it's just can overrule some local siting if the siting if it prevents renewables from coming on. And so that is a permitting option that we have if the county option does not become available for us. And pretty much that. Once I permit the project, it'll be ready to be constructed. Really more right now, honestly, our limiting factor is working with Avista to make sure that their network upgrades are complete for us to bring our project online.
It seems like there are interesting opportunities even for our graduate students to get involved in these, because you also have some job opportunities there. So if someone wants to get involved, what type of expertise do you need? Is it better for students to have expertise in simulating power systems, the interconnections? What type of expertise are you looking for?
All of it. So Adam, that's what his background is.
So it seems like you work with PSSC quite regularly, right?
PSSC, that's the group that's studying creating the group, trying to make the Pacific Northwest a transmission, single source transmission operator like MISO. That we work through them through our advocacy group, Renewable Northwest. So that's actually I work with Renewable Northwest, who kind of making sure that the policy that comes out in this region is beneficial to projects that we want to bring online. But directly, and that is a path. With our team, it'd be someone with Adam. And I guess Adam, kind of what's the skill set and background that you and Curran have?
What are you looking for applicants, students, if they wish to apply?
Mostly understanding what goes into a power flow. a lot of the software you will learn on the job. So I don't think it needs to be specific, but understanding the inputs and outputs of a power flow simulation and kind of in general how the transmission system works.
And it's actually like huge value for having like Adam on our team is, so when we do our own analysis in parallel with the utilities and transmission operators for like our interconnection studies, is they'll come back and say, hey, we think your network upgrade should be $50 million. And then we'll push back and can have, sometimes we've had some wins where we've been able to reduce our network upgrades because of mistakes that they've made. And we'll kind of like that feedback loop there. If you guys want to do what I do, I find my job's fun. It's a big mix of like lobbying, project management, and sales. So having to understand everything that's going on, communicating it, overall running every aspect of the project to get it to be ready to be constructed. Now we've got, yeah, for you guys, Adam's team is probably the most directly applicable. But then Vestas as the big turbine manufacturer, I think they're a lot doing design of like protection systems and making, making sure the components work with like the utilities and every, having a global market, every country's grid is different. And so making sure when we manufacture our turbines, they play nicely with like the grid.
Yeah, even the generators inside these turbine.
Yeah.
So you don't do any projects for that design, right? Do you have any specific projects for the design of the generators, or is it coming from somewhere else?
So my team does not, but Vestas does. So like, yeah, on the manufacturing. So I think we procure a lot of the components from other places like Siemens and things like that. But I think a lot of what we do in-house is just overall design and integrating all the components, and then a lot of the software for both making sure everything plays nicely within the turbine as well as with the grids. Do you know more about that, Adam, on like what capabilities Vestas does on?
No, we don't talk to them.
I want to ask about the economics of like having these turbines. You wouldn't own the generation, is it? Or like you will sell the power and get money from it, or is it leased to someone like Avista or some other company?
So totally depends. So our team's business model is actually just to sell the project right before construction. There's a lot of companies that are on the flip side of it, where they're, IPPs that want to own the project, or utilities will buy the project. And the IPPs will buy the project and then essentially have a PPA and selling the power to somebody. Or like, if Avista were to purchase this project, they would just own the project. They wouldn't be buying the project power. Their cost would be the upfront of buying it and the low cost of operating it. It depends. It's interesting because, the market is pretty, like, a lot of people want our projects, and then the value is just different depending on who you are. And so it's, interesting. You can see a vast difference in valuation of project if you are a utility compared to an IPP, and the way it's structured. It depends. It also depends on the time. And like, a big question that comes up is everyone's like, oh, Trump's getting rid of the IRA and all these Green New Deal subsidies. Are you worried? And it's like, no, until like, if I were working on federal lands or offshore, those projects are not going to do well right now for the next 4 years. But luckily, all my projects are on private land. I don't foresee him coming in and banning wind in the country. It'd be hard to do that because the federal government doesn't really have that jurisdiction of like siting and permitting on, earth stuff that right now is the county and the state. And there's just the need for energy. So while the subsidies do help bring the cost of our projects down and make the finances work, I think more it's that the need for energy is there. So really what's just going to happen is the cost of our projects are going to go up without the subsidies, which means the cost, the amount that utilities are going to have to raise their power prices to bring the power on is going to go up.
But I still see many signs that say no to wind power.
Yeah,
wind turbines.
The group here is very, very vocal, very passionate about making sure that our project does not come online.
I kind of have a question following up with that. How involved are you guys in the information space in that regard, because you outlined very well like the benefits of these projects. I guess like from my perspective as just like a local person here is, yeah, I see all those no wind turbine sign, but there's no like counter movement really, or like people highlighting these benefits. Like what level are you guys like involved in that?
Very. I mean, that's why I'm here today. It's
You don't even know the benefits.
Yeah.
Wrong audience.
it's hard, right? Like we've been in the in this community for 3 years, and we've been on the news. We held a public meeting in February up at the Lewis Alumni Center. We go to these like public meetings, and I appreciate that you guys trust the information. I have to say, there's a lot of people in the public that me getting up there and saying this stuff is they say, oh, he's paid to say these. It's not true. This is a lie. And so it's more of trying to find, it's something we have not been able to be successful in yet, is finding people who are trusted messengers to get this across, because I'm not the right person to do that. I don't know, Eric, anything else you want to add on to that?
No, not necessarily add on. But I would say that, to the point that the question gets to is that we're really engaged in wanting to make sure that the public has an opportunity to give feedback on the project, that we're listening to folks, and that there's a dialogue happening. And so that's really what this kind of stuff is about, and all the public meetings that Shane's talked about and our media opportunities. So we're trying to make sure we're engaged in a dialogue with the community in every place that we do a project.
Yeah, and like I think a difficult thing is, since it is such an iterative process, is like we need the land, we need our studies, like going back to this setback slide, I think just does a good job of iterating of like, you can start with, oh, all that white, it just looks like it could be buildable, but at the end of the day, it's literally just those little sections. And that's changing on a regular basis. It's not until we even have a design that people are like, oh, you're being shady. It's like, well, no, this is just, we're communicating as much as we can as we're the process that we're at. So it's hard when people say like, there's going to be turbines everywhere, it's going to be noisy. And it's like, no, I know that's not the case, but I can't give you real values until I actually have a permit to present and showing you exactly what I'm going to do. And we're finally kind of getting there. But it's just, it takes a long time to do so. So it's very easy for people to come and say that we're being shady and hiding things and not truthful, when we don't have something to directly counteract and say, this is exactly where turbines are going to go. This is the impact we're going to have, because I don't fully know that answer right now, but we're actively working to answer those questions.
So you said that this is slide, you said that the popular one is 4.5 megawatt turbines. What's that the case? So why not larger one? So
depends on where you are in the country, and essentially, there's like a just curve of like, the bigger the rotor diameter, the more efficiency you can do.
Probably is sweet point between the size of the equipment that you have.
Yeah, so size, we're kind of reaching a limit for onshore. I like this. I would be surprised if we find onshore turbines that are much more bigger than this, just because of the ability to transport them on roads and rails. But the weight limit, you have to like deal with the curves of the road. But why 4.5 megawatts is because the really wind speed, this is a very strong wind speed area. And that's like, this turbine's actually going to do great here. But, compared to Iowa, it's a lower wind speed. So somewhere that's a very windy, you get the plains, that you can have a higher megawatt turbine and still maintain that higher efficiency value. Whereas here, just when it makes more sense to have a 4 megawatt. And honestly, I don't know why this just seems to be what our Vestas is designing around. Like the product offerings are like limited. And so this is really what they put a lot of work in to make sure it works the best.
Do you also install offshore wind turbines?
Yes. Yeah, those ones are big. That's like, when you look at Vestas, the V163 that's the rotor diameter. So it's going to be a 163 meter rotor diameter. Each blade's 81.5 meters. Offshore, the turbine we're selling is 236 meters. They're big. And those are 15 megawatt machines. Oh, question.
What can you expect the lifetime of these turbines to be? Like, how long do get a return on that spend?
So right now we're targeting, and what Vestas tells us is the lifespan's 30 years. Now realistically is 30 years. Anytime you want it, like the component that's most likely going to fail is the gearbox, because that's the one that just has the most stress as it's transferring the rotor into the generator. But those probably, you'll start seeing some of those fail at a higher rate after like 10, 15 years, but those will get replaced. But I think overall 30 years, as technology improves, I think we've seen some older projects get repowered. So either just replacing the components to last longer, or like, you'll take the towers, keep the tower section and completely replace the nacelle and the blades with a newer technology, or take everything out and just put a whole new project in. And I think the factors that kind of go into that are both technology improving, and it is driven by like tax credits. And if it's like, financially beneficial to do so.
I have a question related to kind of the long timelines that generation faces often. So how much would you say of that timeline is unavoidable versus if there were more resources and manpower available that those steps would, like, for example, interconnection studies and environmental studies, if more manpower and resources were available, how much do you think that that would improve the timeline that generation faces?
I think I know that answer, but I'm going to let Adam take that one.
I want you to guess.
Oh, it's 100% resource based. Like when we look at like BPA and like MISO and everyone, it's just they're understaffed and have a ton of projects coming in.
That's the right answer. For comparison, MISO is working with a new tool that they think will get their process down to 1 year. So that may be kind of the timeline that everyone's going to try to reach for. All these RTOs, all these transmission providers, they have tariff guidelines for how long their studies are supposed to take, and they are going well above it. And FERC is now going to, at some point, start penalizing them if they do not adhere to those. So I think everyone's going to take a look at how they can reduce the timelines.
And then I have a small follow-up question to that. What proportion would you say of the total cost of a project is physical equipment versus things like intellectual property and just the manpower to go into studies and things of that nature?
Majority is a component. So I'd say, a project I recently worked on, 200 megawatts. I think the turbine components are going to be, that's going to be about $250 million to buy the turbines. It's going to be $130 million to construct the project. Has about $20 million of network upgrades, plus probably another like $15 million of just like the development costs to get that we kind of put in to get it to be ready to be built.
I just noticed that you joined us.
Yeah.
That was a good question. So when he asked you, want to ask question?
Well, we got a question back over here.
Put you on the spot.
Next one, yes.
Yeah, we got a question in the back over here.
Yeah. What is the efficiency? The efficiency.
And what? Efficiency. It depends. So when we look at efficiency, we're looking at that there's 8,760 hours in a year. And then we're looking at, of that time, we expect the wind to be blowing within, like when it's less than 4 meters a second, it's not producing. And if it's greater than 25 meters a second, we shut it off to protect the turbine. So then, and then there's like maintenance time. There's like other, a lot of things that just kind of cut that down. So when we talk about efficiency, we're kind of talking about hours of the year of full operations. And so this project here that I'm developing, we're kind of looking at, it's like the 33 to 35% range. Places in Iowa, you're looking at like 45 to 50%. But yeah, depends on where you are. Is that kind of the efficiency question that you're looking for?
Yes.
Yeah.
What about if you just exclude the time that the turbines are off? What about the time that they're operating in full power? What is the efficiency?
I guess, are you saying, like, are we taking energy that the wind and
Yes.
Yeah, I don't know those numbers and what those losses.
Otherwise, the 30% is really low.
Well, it's significantly higher than 30%. That 30% is like I turbine count, but yeah, that's a good question. I don't know what like.
Yeah, because into the 30%, maybe 1 year it's out of service because of some maintenance.
Or
But
sometime.
we should not count it towards efficiency.
I also think efficiency is not a good metric to be like, comparative to other generation sources, because this is like the fuel's free, right? Like this is, we're just putting a tower up and it's creating energy. So like it's either the wind's blowing, not like the physics of the earth is what's causing the wind to blow, and we're capturing that. And so when people talk about efficiency, I think it's very easy to be like, oh, wind's bad, it's only 33% efficient, where this, gas plant is 100% efficient, which isn't true. But that's like a metric that people will use. And I think, it's more of that we're putting, we need all the energy sources we can get. And this is a source that we're just putting up a tower and collecting the energy from the air. And we're not having to mine fossil fuels and transport the fuels and burn it. So, yeah. And then it's different than I think like a heat engine of like efficiency.
But those people that they say that mainly they concern about capacity, but they say that you have installed 200 megawatt wind farm, but it is equivalent of, we say that 30%, it is like
67 megawatts.
60 megawatts. So they say that.
Yeah, and that's something that when we bid into RFPs and things for like Vista's having an RFP that's coming out, and they're looking for 200 average megawatts. That means we're only going to be able to bid in for like 67, which is like, but we need more energy. There's this demand. And
You might have mentioned this and I didn't hear, but what type of turbine? Like, because I learned about like type 1, 2, 3, 4.
Oh, I'm not sure what that
That was also my question.
I think we're at type 4.
Okay.
What does that mean?
It's how they model it in the power flow system.
So you use permanent magnet machines, right?
I don't know. Do you know, Adam?
No, it's just a couple squiggly lines when it comes to us.
Yeah, because usually at the beginning they were talking about type 3 had more kind of interest in that one, but then the cost of gearbox, those kind of things went up. So, and I hear people say that type 4 is something.
Yeah, that's like a big thing is you want to make sure your operations costs and are minimal and like maintenance costs. And so I think that's a lot of what goes into the design is efficient, like that the machine itself is efficient, but also the ability to maintain it and replace components.
That was mainly that gearbox.
So do you see a value for storage in your plans as you're developing them? And maybe a better question is at what cost point storage becomes useful as a resource with the wind?
I don't, right now, none of our projects are planning to put storage. On like a science side, it seems like it makes sense. And it's like, okay, the wind's not always blowing and we want to be able to do it, to like store the energy and dispatch it when it's actually most needed. My understanding of just talking to people, like at least on the financial side, that it's more of an arbitrage case and it's hard to make the numbers work, especially with like the cost of the components. But I do know a lot of projects are doing it. We have not done that yet. Adam, do you have your thoughts on storage? And
you said the magic word of arbitrage, and I think that's where it makes sense. So maybe in California, that we don't look, personally, our development shop doesn't look for a lot of projects in California. That's one place that would make sense.
It's basically the market mechanism that's kind of prohibiting in getting additional value that you can unlock from wind resources through storage. Is that what you think?
Yeah, essentially cost prohibitive.
So if there were mechanism like California here that allows you to arbitrage energy, then are you saying that storage is beneficial with wind right now and people are actually exploring that option?
Yeah, I know a lot of projects that are like wind storage. When like, look at Horse Heaven, which is in Central Washington, that's wind storage solar all in like a single project. It's just not, it's also interesting since our team is part of like a wind manufacturer, our primary mission sets to like develop projects to sell wind turbines. So while I don't know if we've done as much research and like have as much push to do storage, just also because our like mission set's different. But you know, a lot of developers are including storage in their projects. So it does seem to make more sense with solar than it does with, or I don't know if it makes more sense. I'm seeing it more often with solar.
The reason I was asking is that we keep hearing that storage cost needs to come down for it to be, useful, make it a good use case with renewables. So I was just curious that if you have looked into what cost storage makes practical sense for it to be more widely deployed.
I know people on my team have. I don't have that answer. In my mind, like, so you could get storage to have, I think, a longer duration. It would almost make sense to have storage up front and have all your renewables coming in, and then you could just have the storage be almost like a traditional generator that's dispatching at all times. But that does not exist right now.
So then in that case, if you don't have a storage, maybe that's a little bit technical thing, but how do you meet the, for example, grid code requirement? So, for example, grid code says that you have to inject a certain amount of reactive power, I don't know, active power here. So then are you underutilize your?
I'll start this answer, but I'll have Adam finish it. So my understanding is that you're looking at like the day ahead, and essentially like, okay, we expect the wind resource to be this tomorrow, and then they'll like plan for that. And like, okay, we need to stack these other sources to meet our full need. But I don't know, Adam, do you have a more detailed answer as to like how we meet requirements?
Yeah, that's for the transmission provider. For our plants on their own. Shane mentioned the BOP, the build of plant. So besides the turbines, we will also determine if we have enough reactive power for our plant. And we usually wind up adding a bunch of capacitors as we're building it to ensure that we meet all of the NERC criteria.
How about, for example, frequency requirement? Then in that case, you should have some active power resources too.
I'm not familiar with that.
Yeah, probably. And do you know that if those wind turbines are grid forming or grid following?
Typically they're following.
Oh, okay. So then that would be interesting to see that how you meet the frequency requirement. Yeah, okay. But you don't use capacity storage. That's the bottom line.
We don't use storage, yeah.
Okay.
Question back here?
Yes, so you mentioned even before laying out the land, you conduct some research. There in order to see that land in that topology is beneficial to you. Once you've sited such land, you lease it out for 50 years. You mentioned on slide 4. I would suppose it's beneficial that if you want to maintain your resources in that area, you would release that land.
Yes.
And then, so suppose that's another 50 years. Your wind turbine average is 30 plus years, as you call it. Then there are two parts of it. What's your approach to it? So the lease period is still there, even though you will release it. So you would want to invest another, reinstall another wind turbine there. Is that the case? And the question following that is, what happens to the old one? Do you have a recycling facility? What do you do with all that?
Great question. So yes. So first off, like the fact is so difficult for like these projects to get developed. So not only there's all these steps at any point in this process, like as developing a project, there's something that might happen that causes it to fail. Maybe both either on the company side, the money doesn't make sense, the projects die. Like of every project we start, or every 10 projects we start, only one's probably making it to construction. I think once you have like a constructed project, renewables are still really young in this country. So we're not even seeing like getting the end of some of the original leases that were signed. But my expectation is that those are going to get re-signed and repowered just because you already have all the infrastructure there. You already have like the ability to produce and everything already set up there for a project. So yeah, in the original 50-year term, that is 100% the expectation. I expect that those components are going to be either we're going to go in and replace all the gearboxes, generators, the internal components to make it last longer, or you're going to just take it all out and put new turbines in. And then to the question of what happens to the old components, if the nacelle is actually some of those old turbines we're like reselling to like other countries as refurbished and sold elsewhere. But then you can also recycle the metal if you really want to break everything down. And there's been a lot of work for blade recycling, just because that's been a concern. There's some images, places of where there's like blades and landfills, and that's a visual that does not look good on the industry. And so Vestas has been a leader in making blade recycling processes to make sure that I think long term the goal is to be able to reuse it in other fiberglass or blade making if you could break it down. Right now those materials or processes don't exist, so it's really they're just like ground up and like used in like cement or something. Yeah, did that answer your question?
Yes, that gives me an idea. Also, like English is not my first language, so please pardon my naivete of this question. What's the meaning of word Vestas?
That's just the name of the country or company. I have no idea what it's a Danish company based out in Copenhagen, and that's just the name. Yeah, I don't think it. If there's a meaning, I don't know it. Steelhead though, that's a trout. That's a type of fish.
Yeah.
I have another question. So how much of your supply chain is based outside of the US? Like I was wondering if you foresee any impacts with like the current trade policies.
Yes. So we do manufacture our turbines in Denver. But I think we still source things. Like we're a global company. I think that's a big discussion right now in figuring out in turbine pricing. And I just assume that turbine prices are going to go up with everything going on.
That will make people even more reluctant to go towards wind, right?
I mean, it seems like everything's going to be more expensive. Like I don't see any industry that's that's being like hardened. And the other thing is, especially like I have a project that I could start building in a couple of years. Like we have the ability to do it. You look at other sources of energy, and everything's so backlogged. You want like a gas generator, like the earliest ones that you can buy a new gas turbine is like 2030. Nuclear, I come from a nuclear background. I think nuclear is great, but just the permitting and we don't have the manpower and the skill set to start building nuclear on a large scale right now. So this is an industry where it's like we're ready to go. It's very available. And I think even if components go up, it's still one of the most affordable sources.
You mentioned it's a Danish company, so around their part, Aalborg and all, they're working on offshore a lot. Danish companies coming here to work onshore as well. Interesting.
Yeah, I mean, I think Vestas is just one of the leaders of like wind turbine technology in general. And so we've been here since the beginning of wind power in the United States.
That's the free market. That's the sense of free market.
Let them work.
Opportunity.
Other question? Okay. Yeah, one quick one. So for the considerations that you make before the building process, I kind of understand the majority of how those would impact how you move on. I'm curious about how the environmental study moves forward. Does that end up being more of a binary where you say like, okay, we've looked at it and we can't build here without significant impacts, so that's just a no on the project? Is it more often like, okay, it just adds to your map of we can't build in these locations? How does once you finish the environmental study, what does that usually look like for the rest of the project?
So yeah, that's a great question. So both on the front end, it's like if there's an area of like it's a habitat for an endangered species, we want to stay away. So that we won't even start going there. So that's something we'll know going into it. I think as you go through the project, you do studies, or a new species becomes listed as endangered. That can also be something like once we've started developing a project. So then it's looking at ways of mitigating it. Right now, bats is a big concern. And like here, there's not as large of populations, but you're looking at the southeast of the United States, and like that bats are something that they impact wind turbines a decent amount, higher than most other things. And so there's curtailment strategies that you work with, like we would work with the Fish and Wildlife Service, say, okay, like during the spring and fall from, at dusk and dawn hours, if the wind speed is less than 6 meters a second, we're still not going to let them turn on until greater than 6 meters a second, because we know that greater than 6 meters a second, bats really aren't flying. So it's like, you can program the turbines to mitigate any impact to species like bats, knowing what their flight patterns are, that we'll study and make sure, okay, if it's windy, they don't fly, and they're also not flying during the middle of the night, and they're not flying during the middle of the day. So these hours and these wind speeds will just keep the turbine curtailed. So that's something for like bats. And then, more like ground species, like in Kansas, the lesser prairie chicken is kind of an endangered species. So you have to go and map and find where their nests are and just make your site like a mile away. I know a big thing in Washington, luckily there's no ferruginous hawk here in this area, or in our project area, but ferruginous hawk, you have to site 2 miles away from their nest. So it's a lot of working with the state and federal Fish and Wildlife Services to find mitigation strategies that allow the project to come on, but still like mitigate an impact to a species. And then the other thing projects have done is like, okay, we're impacting taking this certain amount of habitat away. Part of our project requirement for a permit or for a project to come online is we have to now create equal or more habitat elsewhere for a species.
Okay, so just to summarize the tools that you have available, you basically have turbine placement, turbine controls, and then investment elsewhere.
Yes, exactly.
Okay.
That was
Hey, Shane.
interesting. So,
Shane,
yeah,
I
go
need to drop. I would just say before I leave, to follow up on the question about jobs, my boss and I both came from an RTO background. I would say that if you're coming out of college, like that's one of the best places to get a lot of knowledge about the industry in a short period of time. So I would encourage anyone who's interested in transmission to look for something like that. And it's a great stepping stone to a job at a developer or an independent power producer. Shane, feel free to give out my contact info if needed, or they can send questions, technical questions through you, but happy to follow up afterward. Appreciate everyone.
Awesome. Thank you, Adam.
Yeah, thank you, Adam, for taking time and providing such useful information. Thank you. Well, that was interesting. So you're saying that even for environmental concern, basically operation also you take into account. So
Yes.
basically saying at some time of the day you do some curtailment.
Yep.
It seems like we have to consider the flying pattern of
Yeah, that's what I'm
bats
Never
in our
considered
simulation.
And that's
our model.
and what is that? You keep monitoring that one or not? You have some pattern. You're saying, okay.
I think it depends. And I know I have our environmental director with us. We can speak more to that. And he's the one who kind of leads our environmental team of like working with agencies to create like, strategies that making sure we minimize impact and still have the project. But yeah, there's actually regulations for bats specifically from like the Fish and Wildlife Service that can show you different regions, because have different species of bats, and different species of bats have different flying patterns. But that's, I can find it and send over like what those curtailment, that's a public thing, and that's just kind of standard. Like you're doing a wind project in this area and you think you're going to affect the tricolored bat, you have to like during these times of years and times of day, like have those curtailment strategies.
But that is fixed. That it's not.
Well, I mean, I'd say it's changing as like more data comes up, but it's fixed for now. Like there's guidance, and then the Fish and Wildlife Service will update their guidance.
New research idea.
Yes. Do the deep learning and the pattern.
How would a land species, like a ground species, be impacted by a wind turbine? Is it just during the construction process?
Yeah.
Okay. Like, is there maintenance around a like wind farm that like I don't know. I don't know very much about it. Can you like let like trees or like ground bush like grow around? Like, are there regulations with how tall they can be or anything like that?
Yeah, I mean, essentially, we don't want anything that's going to impact the wind, like speed. But I mean, like you're still, trees can still grow nearby, but you just don't want it to go above like 80 feet or something. But really, the maintenance is more of, kind of like your car, of like, after the construction period. So yeah, the impact to your first point, construction is the biggest impact because that's where it's like we have very wide roads and you're digging up through the ground for our collection lines. And our pad for constructing the turbine is very large to support a crane. And the roads are big to support cranes walking on it and the transport equipment. After construction, everything's kind of tightened back up. That the pad itself is probably about a quarter acre. And then you got like a 16-foot wide road just to access it. The normal like a technician can drive up to it and there's to park and a pad. And then the maintenance is like an annual oil change. You might go check and see that it's faults and you have to go check and see what faults are. Maybe like circuit card replacements and things like that. But it's pretty minimal. And then, as you get later in life, you'll start seeing, still rare, but like a larger component failure, like a gearbox or a generator or something like that.
Are you using any of the AI algorithm anywhere in the whole process?
Can you ask that again, please?
Are you using any of the artificial intelligence-based algorithms anywhere in the whole process here?
Not that I know of, not yet.
Not even there in the.
That's kind of hard. I don't know how many landowners would want to lease with an AI, but yeah, I'm sure. Honestly, I think the place that could use it, and you guys probably know more than me, but it's how the systems study our projects. And it seems so like basic. That like wind isn't of a 200 megawatt project isn't inserting 200 megawatts all the time, but they'll study it as if when we do our network upgrades, as if we are inserting 200 megawatts 100% of the time. And making sure, and then they build in the buffers. And so it's like our upgrades are definitely overkill because we'll never reach the capacity that they're studying for our project.
So to increase overall efficiency of the process.
Yeah.
Being calculated.
I think if wind and just in general things were studied better, it would reduce the amount of network upgrades, which would reduce the costs on our project and still make sure that you have a resilient grid system.
I heard that some people, a few years back, I heard that, especially for those paperwork of the contracts, those kind of things, some of companies, they use AI. So they want to automate that part. I don't know about the system studies, but as far as those permission things, I don't know, paperwork. I remember one of my friends was working on that.
Cool.
I vaguely remember that he was saying that. But most of these contracts basically like a template. So maybe.
I have another question. So you said you also do lobbying. What kind of things, like more specifically, do you lobby for? Like, what are the things you're pushing for?
So I'd say twofold. One is like just the engagement with the local commissioners and like the local stakeholder decision makers for our permits. So it's a lot of just like government, whether at the local level or state level. But then it's also on policy. So like I've been working hard with the Washington legislature this year they've got some tax legislation for how renewable projects are taxed. And so making sure that legislation actually is beneficial for our projects. So things like that.
Yeah, makes sense.
Big question? No? Okay, thank you very much. We really appreciate for such an informative talk. So that was usually we go through technical things, but you gave a broader view of the thing. We really appreciate that.
Yeah, I hope
I'll give a round. But we have lunch.